Hello students, today we are going to discuss about the problems in dipole moment of electrostatic topic. So already theory concepts is complete in the previous videos, just you can check it if you want to refer. So we are going to do the problems on that dipole concept in the electric field concept based problems will do. Now look at the first question in this. This is one of the question. Two small identical electric dipoles, AB and CD. Which is AB? This is AB, one of the electric dipole. One is having negative charge, one is having positive charge. And CD, positive charge and negative charge. These are the two dipoles. Each of dipole moment is P and kept at an angle of 120 degree separation. You can see in the diagram very clearly given. This is the angular separation between these two. How much that is? 120 degree separation is given. The first question asking, what is the resultant dipole moment of the system? What is the resultant dipole moment of the system? To understand the resultant dipole moment of the system, first, how to solve the concept of this, dipole moment. To understand this one, dipole momentum is a vector quantity, so it is having particular direction. Always, you know that it is from the negative charge to the positive charge direction. So, in the case of AB dipole moment, this is the direction of the dipole moment for the AB. So, this is the one of the dipole moment for the AB dipole moment. Now, if you come across the case of next one, CD. CD dipole moment also negative to positive. In this case, negative. In the point of D, we have a negative. In the point of C, we have positive. So, this is the way the direction of the dipole moment in the case of which one? In the case of CD. This is dipole moment P in the case of CD. So, two dipoles are separated by how much angle according to given diagram? These two are separated by an angle of 120 degrees is given. Now, with respect to x-axis, if you take a coordinate system, if you taken, this is the way I can choose the coordinate system. This is the way I can take the coordinate system x-axis. Coordinate system x-axis I can take it, and y-axis, this is the coordinate system I can take it for another one. Y-axis. So anyway, if you observe this one, with respect to x-axis, you don't know how much angle it is making, so we'll discuss later about that. So first question is, what is the resultant dipole moment of system? So two dipoles are vector quantities, so two vectors separated by a certain angle, so the resultant dipole moment, that is called as nothing but PR. Resultant is equal to, according to parallelogram law of vector addition we use, because two vectors separated by a certain angle, the resultant always in the direction of the resultant of the two vectors you have to take according to parallelogram. So if you say one dipole moment, that is I am taking as P1, second dipole moment if you take it as P2, so both dipoles are having same dipole moment, each of dipole moment P, so that means I can write as, simply don't write P1, so you take it as P only, and this one also you take it as P only. You take it as P, in this case what I can write, that is PAB square, first I am writing the formula, plus PCD square plus 2 times of dipole momentum of AB, dipole momentum of CD into cos of the angle between them. So if you apply all the conditions of this one, resultant dipole moment is equal to, in terms of magnitude, this is we are doing, so that is under root of, so what is PAB square? That is nothing but B square plus P square plus 2 P into P cos 120 degrees is the angle between these two. Look at the diagram, 120 degrees. So if we solve this one, so cos 120 is nothing but 1 by 2, 2 to get cancelled, we are going to get, this is root 3 P here. Root 3 P. Root 3 P means nothing but the dipole moment is the concept of, how much? Root 3 P. So this is the resultant dipole momentum of the system of two dipoles separated by certain angle here. This answer for the first one. Now second question, what is given in this system is subjected to electric field E in the direction along positive x-axis, means this is the direction we are applying the electric field. So when you apply the electric field E in the x-axis, what is the magnitude of direction of the torque acting on it? So what is the torque they are asking to calculate? What is the magnitude of? Means only value they are asking how much it is. What is the formula for torque? torque acting on any dipole is equal to, that is P into E into cos theta is the formula for, sorry, sin theta is the formula for that, right? P is sin theta is the formula. So in this case, sine of the angle we need to find. That means what is the angle between the electric field vector and momentum vector we required. This is the electric field vector. It is anyway along x-axis now, but dipole moment direction, resultant dipole moment direction is not given. So if you see this one, this is the one of the dipole, this is one of the dipole. Both are supported by an angle of 120. Both are supported by an angle of 120. In this case, the resultant dipole moment which you are taking, that will come in between these two. 120 means what is the angle? It will come in the both are equal magnitude, means it will come by subordination of 60 60. That means I can write here, from here to here is, that is I can write as 60. From here to here is also I can take it as 60 degrees. So if you want to find the direction of in this case how much angle it is, the resultant will be exactly diagonal, right, in between. This is 60 means how much angle it makes here, this angle will becomes with respect to x-axis 30 degrees. Yes or no? Because from y-axis to this 160, that means with respect to x-axis, that is 30. Means the dipole moment, which dipole moment? The resultant dipole moment and this electric field both are separated by an angle of how much? 30 degrees. This is we need to find. So the angle between the dipole moment and electric field is 30 degrees. So theta is equal to, from the diagram we have to identify as 30 degrees. Now calculate the torque. Torque is equal to nothing but, so the magnitude of the P, magnitude of the E, and the sine of the angle, that is 30 degrees here. So how much 30? Sine 30 is equal to 1 by 2, that is nothing but P by 2 is the answer to your question. So first question, resultant dipole momentum is root 3P, and what is the torque acting on that one is equal to P by half of the maximum torque. Now look at the next problem. In this case, they given one of the linear electric quadrupole. Quadrupole means how many charges we have? 4 charges are there. Look at here, this is plus q, this is minus 2q, that means 2 minus charges are there, plus 1q. Total is 4 charges of same magnitude, but nature is 1 is 2 are plus, 2 are minus, like that. So that means in this case, here the middle minus 2q, I can take it as, okay, 2 types of minus q I can take it. Now plus q minus q forms one dipole. That dipole moment I can take it as P1. This is the direction of the dipole moment, which you can see. This is the direction, okay, right to left. And second dipole moment, 1 minus and 1 plus combination acts like another dipole. The direction of that one is, okay, that is left to right. You can see that. Now in this case, what they're asking, find the expression for field at a point axis of the quadrupole. Means they're asking to find the electric field intensity due to this 4 charges system along the axial line. So that means this is the axial line. If you taken on this line, they're asking to find the electric field intensity at a point. So choose the point anyway. I'm choosing the point here, that is the point P. At this point, we need to find the electric field intensity, suppose. So to find the electric field intensity, suppose first the distance of the point always we have to choose from the center of the dipole only. So that means from here to here, the distance of the point we chosen as R. If R is the distance of that one, in this case, L, total distance between these two is equal to 2L. If you say, that means the distance between the minus q to this is equal to how much? That is L by 2. This is also becomes L by 2. Total becomes how much? 2L. L plus L by 2. So this is total is 2L. Total is 2L means what is the length from the one of the charge? From the length from the one of the charge is, this is L, and from the center this is also L. Now from the diagram, I can write the distance of the positive charge from the point. That means first this q. This q, what distance it is? Total distance of the point from the center of the dipole is R, and this charge is at a distance of, I can write as R minus L. Similarly, for the second charge, this end positive charge, what is the distance from the point? This is that is at a point of distance from here to here is, it is L. From here to here L. From here to here is R. Total distance is equal to the total separation is equal to I can write as R plus L. Now, what is the distance of the middle charge negative? That is anyway already be taken as R. Now, there are different types of electric fields are there. One or two positive charges are there. There is electric field at that point, and 2q negative charge is there. There is electric field at that point. So, due to the positive charge, the electric field at that point, that is I am taking as this is 1 if you say, this is 2 if you say, this is I am writing as 3. So, electric field due to first charge E1 is equal to I can write as 1 by 4 pi epsilon is a formula, that is I am writing as k into charge q by square of the distance. What is the distance of that one? R minus L. This is the distance of that one, so I can write as R minus L whole square. Similarly, electric field due to second charge, that is also formula is same, 1 by 4 pi epsilon charge is q by distance, square of the distance. What is the distance here? Second charge minus plus q, and the distance of that one is R plus L, so I can write as R plus L whole square. Next, if we come across the case of third one, what is third one? E3, third charge. Now, what is the third charge? That is minus 2q. So, what is the distance of that one? That is R is the distance of that one, so I can write as k into, that is nothing but 2q is the charge, by distance is square of the distance you have to take, that is R square. You can take minus in the charge, or you can take the minus in the case of derivation. Now, here how many electric fields are there at that point? 3. So, what are the directions of the electric fields? If you come across the case of the directions of the electric field due to plus q, this is the direction of the electric field for the first charge, and due to second one also same direction. Second one also the electric field direction will be same. This is the direction of the electric field due to second one, and due to third one minus 2q. What is the direction of the electric field? This is the direction of the electric field like that. So, 3 electric fields are acting as they are looking like. So, this is the first one E1, and this is the second one E2, and this is the third one E3. So, if you see this one, now what is the net electric field? Net electric field, two positive charges are there. So, at that point, electric field intensity at that point is equal to net electric field is equal to, I can write as E1 plus E2, both are acting in the same direction, minus you have to take as E3. So, now you have to take that concept of equations and you have to solve it. So, EP is equal to, what is E1? Common terms you take it, KQ. E1, E2, E3, what is common? This is KQ. Here also we have a KQ. Here also we have a K into Q. You take it common. If you take a common of that one, I can write, that is 1 by R minus L whole square plus 1 by R plus L whole square, and minus E3. E3 value we have a 2 is there here, 2 left, that is 2 by just R square. You can check it properly if you are missing anything. So, now you have to solve that one by taking the corresponding LCMs here. So, if you take the corresponding LCM, so in this case, what is the electric field? Due to this, you are going to get EP is equal to KQ into, take LCM of this one. So, I can take the LCM here, 3 of this. If you take an LCM, what is the LCM? I can write R minus L whole square into R plus L whole square into R square. If you take an LCM of this one, so first term you are going to get R plus L whole square into R square plus R minus L whole square into R square minus, this becomes R minus L whole square into R plus L whole square. So, this is the way we can write the expression of this. Now, you have to solve this one to get the result by taking the, this is A minus B whole square, A plus B whole square, that is nothing but A minus B into A plus B is A square minus B square, that whole square you have to take, and in the denominator also by multiplying, and by taking the minus common, and after following certain process, we will get the one of the result, that result we can find it. Now, next step, I can write KQ into, here this is in the form of A minus B, A plus B. So, I can write, first this we can write as A square minus B square form. So, that means I can write as this totally term which is I am making here, I can write as R square minus L square whole square. And in this, I can take the r square common here because we have a denominator r square is there. Denominator every term contains r square, so you take the r square from here. If you take the r square from this equation, if you take the r square, the term will becomes 1 minus L square by r okay, L square by r square whole square. If you multiply inside, again you will get the same thing. So as before. So if you taken r square, so common, here r square, here r square, if you taken common, so after cancellation with below, we are going to get r plus L whole square plus r minus L whole square and minus, okay, that is 1 minus L square by r square whole square total divided by this becomes r square minus L square whole square. So if you want to, okay, if you want to modify this one, you can modify according to our requirement condition. So here, practically, if you come across the distance of the point is always we are taking by considering as length of the dipole is much smaller than compared to distance squares. In that cases, L value almost you can take it as 0. Okay, if L is less than R means L square by R square value almost you can take it as 0, and L value also you can take it as 0. So in this case, what is the equation you are going to get? That is nothing but KQ into, so the term bracket terms which are written R square plus R square, that is nothing but 2R square you will get, and this is becomes minus 1 into this becomes anyway, okay, L square by R square value becomes 0, that is negligible, that is become it as 1 like, almost you can take it as relation as 1 like, minus 1, that is becomes minus 1 by denominator we are going to get r square, that is r power 4 here. So if you observe in this case, so the electric field intensity, how it is related, the electric field intensity at that point is inversely to fourth power of its distance. In the case of dipole moment, it is inversely to 3 power, but in the case of quadrupole, the electric field intensity at that point becomes fourth power of its distance of that point it becomes. So if you are neglecting the length of that one, according to that you will get the modified equations. That equations you can